Hello class, today we're going to be talking about another conic section. In the second conic section we're going to be talking about our ellipses, and you may recognize this shape as an oval, but the definition of an ellipse is defined by 2 points called foci, and such that every point on the ellipse, the sum of the distances from the point to each foci is the same. So let's take a look at an example. Here I have this point, and the distance from this point to the first focus is this value, and the distance from this point to the second foci point is this distance. And as we move the point around the ellipse, the distances are changing, but what doesn't change is the sum of the distances. In this case, the sum of the distance is 14.3. So that's what defines an ellipse. So if I were to take a line segment and connect the two foci point, I have what's called a major axis. And if I were to continue that line segment to where it intersects the ellipse, then I have what are called vertices, which are the coordinates of the, which are the points where the major axis would intersect the ellipse. And I also have something called a center point, which is the distance, the midpoint between the two focus points. And if I were to make a line segment that's perpendicular to the major axis and intersects the center, I have created what's called a minor axis. And the points where the minor axis intersects the ellipse are called co-vertices. So I'm going to call them CV1 and CV2. And so now we have 4 points on our ellipse basically defined and related to the focus points and the center of the focus point. So let's take a look at some other interesting measurements that we have here. So let's take a look at the distance between the center point and V1, the vertices. So let's go ahead and take a look at that. And well, what do you notice? The distance between C and V1 is 7.15. The distance between the center and the second vertex is also 7.15. So let A be 7.15. Now let's take a look at the distance between the center and the co-vertices. So let's take a look at that. All right. The distance between the center and the co-vertex vertex 1 is 4.52, and the distance between the center and the second co-vertex is 4.52. So let's make that point, label that point B. So now we have two coordinates, A and B, and they basically define the centers, the distances between the center and the co-vertices. Okay? Let's see what happens when we are to do a simple calculation. And it's important to note that A is 7.15, and it is a result of the distance between the vertex and the center. So the major axis is related to the largest A or B value, and vice versa. For here, the smallest A or B value is related to the minor axes. Okay, so we're going to calculate something, and you guys may remember this. We're going to take our value, we're going to take that, and we're going to take B squared. Oops, let me back up, sorry. We're going to take A squared, and we're going to subtract it from B squared. And let's see what we get. And then we're going to take the square root of that number and see what number it ends up being. And it ends up being around 5.54. Well, what's the significance of that number? I'm glad you asked. The significance of that number is, let's take a look at the distance between the center point and the first focus point. So when we take a look at that and those distances, we see that the distance between the center point and each focus point is 5.54. So we have a way of calculating this distance based off what A and B are. So there's a relationship that's important to note. And then if we let c squared be the difference between a squared and b squared, where a is a larger number than b, then c, which is the square root of the a squared minus b squared, is also the distance between the center and the focus point, as we see here as well. Okay? So let's go to our notes. So as you can see here on the notes on page 131, I've shown you how an ellipse is formed by the intersection of a plane and a cone, but I've also shown you two different types of ellipses. A horizontal ellipse, which we just saw, and the thing about a horizontal ellipse is that it's horizontal because the major axis is the horizontal line segment. And then we have a vertical ellipse, and it's called a vertical ellipse because the major axis is a vertical line segment. And how do we know which one is the major axis? Well, the major axis is always the longer axis, the longer line segment. And in this case, the longer line segment is vertical, and in this case, the longer line segment is horizontal. So let's take a look at our definitions, and you don't have to read that, we've done all that, and we're going to actually look at an equation to describe our ellipse, and that's where it's important. So let's take a look, and if you haven't already, have a pen and paper ready to fill stuff. Okay, so the standard equation of an ellipse, if the center is at the origin, which makes life so easier, is equal to x squared over a squared plus y over b squared is equal to 1. And that's in the case where a is the distance between the center, and the vertex. So that means the vertices are at either positive a, comma 0 or negative a, comma 0. And because the minor axis is vertical, then the co-vertices are at a distance of positive b to negative b. And the only thing that changes is if the major axes switch from horizontal to vertical. So now the major axis is the larger value is a is underneath the y squared, and so we still have the same situation there. Okay? So, and then what about the distance from the origin, i.e. the center, to the foci? Well, we can calculate that distance from the origin to the foci, or the center to the foci, by just doing what? Well, the distance is c, and c squared is equal to a squared minus b squared. So we're going to take a look at some examples to solidify what we've learned. So here we have an equation, and we want to be able to identify the vertices, co-vertices, and foci. But unfortunately, in this format, it's difficult to identify that. So we're going to rewrite it so that we have an x squared over something and a y squared over something, and the right side equal to 1. So in order to do that, we have to divide both sides by 324 so I can get 1 on the right hand side. And when I divide the left side by 324, I get x squared over 36, and I get y squared over 9. So that means that now we are able to identify what our a and our b are. So in this case, our a would have, since a squared is 36, a would have to be 6, and since b squared is 9, b would have to be 3. And since the denominator of the x squared term is greater than that of the y squared term, then our major axis is under the x, so therefore our major axis is horizontal. So that means the vertices of our ellipse are positive 6, comma 0 and negative 6, comma 0. And the co-vertices of our ellipse are 0, comma positive 3 and 0, comma negative 3. And those are coming straight from the fact from a being equal to 6 and b being equal to 3. So if you know a and b, you know your vertices and your co-vertices if you have an origin as a center. And to figure out the distance between the origin, i.e. center, and the foci, we put c squared equals a squared minus b squared. So 36 minus 9 is 27, so that's c squared, which means the distance between the center and each foci is the square root of 27. So that means our foci are located at these coordinates, which is around 5.2, 0. Okay? And we're going to draw the ellipse by basically drawing these points. Which points? We are plotting these points, i.e. this point. We're plotting these points, and we're plotting these points. And when we do that, we end up with this lovely ellipse. Okay? Now, if you want, we can go ahead and I can show you the other examples on the page, or we can work them out in class. Okay, but I think I want to work at least one more out, okay? So we're going to work on the example 2 out. And this time they say, instead of giving us the equation, they give us the vertex and a co-vertex and want us to write the equation. So they give us that the vertex is at 0, 7, which means, our A value is 7, and the co-vertex is at -4, 0, which means our B value is going to be -4. So in order to do, and that's exactly what we indicate here. So if our vertex is at 0, 7, the other vertex is at 0, -7, and since our co-vertex is at -4, 0, the other co-vertex is at 4, 0, and that's only because our center is the origin. And because the larger value, which is 7, is on the y-axis, and that means that our co-vertex is on the x-axis, which means our major axis is vertical, since A is 7, and the minor axis is horizontal. So that means all I have to do now is do a squared plus b squared, and a squared goes underneath the y, and the b squared goes underneath the x, okay? And consequently, now we have our equation. X squared over 16 plus y squared over 49 is equal to 1, okay? And if you want to see the graph of that, we can graph it at first, just based off of the information they gave us, and the equation of this ellipse is such. All right, we don't have time. I really don't want to extend it by further by doing the example 3, but see if you can do number 3 on your own. All right, that's it.